Hello everyone. In this video I'm going to solve this question that is largest rectangle in histogram, and basically is calculate the maximum area of a rectangle in this histogram. Okay, so let's read the statement. Given an array of integers heights representing the histogram's bars height, where the width of each bar is 1, return the area of the largest rectangle in the histogram. Okay, so here we have some examples. For this example, we have this maximum area of 10. Okay, and for this example we have this maximum area of 4. Let's see the constraints. So the length of the array is 10 to the power of 5, so this is really big to use a brute force approach. So if we do this, we're going to have time limited exceeded. Okay, so that's a reason that to solve this question we're going to use a monotonic stack. Okay, and we're going to solve this question finding the nearest smaller element to the left and nearest smaller element to the right for each index. Okay, and this is basically all to solve this question. Okay, so I'm going to declare my variable n that is going to be of size of heights. Okay, and I'm going to declare two vectors, okay, left and right, and it's going to be of size n. Okay, also I'm going to declare my stack. I'm going to call it st, and I'm going to iterate over each height bar of the array. Okay, here I'm going to, okay, I forgot something. Okay, this monotonic stack is going to be in increasing order. Okay, so if we want to find the nearest smaller element, we are going to use increasing order, and if we want find the next greater element, we are going to use a decreasing order. Okay, but for this question we are finding the nearest smaller element, so we are going to use increasing order. Okay, so here I'm going to ask, if my queue has something, I'm going to ask if this rule is met. Okay, so if my height and I is less than equals to my top element of the stack, okay, then I'm going to pop it off. Okay, because we need to strictly increasing. Okay, so after that I'm going to store the nearest smaller element to the left. So here I'm going to ask if my stack has something. Okay, then I'm going to add the top of the stack. Okay, otherwise I'm going to put -1, then this means that we don't have anything to the left. Okay, and after that I'm going to push my index. I hope this is really clear. I'm going to I'm storing the index, and after that I'm going to acceding to this index. Okay, to avoid this I can use a stack of pair the height and index, but I'm do it in this way. Okay, so after that I'm going to erase all the elements in the stack. So while my stack has something, I'm going to pop it off. Okay, and this is basically the nearest smaller element to the left, and I'm going to calculate the nearest smaller element to the right. This is basically the same, but we are going to start in the end of the array, okay? And also we are going to do the same, but here I'm going to store in the right. And instead of storing -1, I'm going to store n, because the last element to, or the nearest element to the right for the last position is n, okay? And the nearest smaller element to the left for the first position is -1, okay? So here I'm going to declare my max area, okay, to tackle the maximum area, and also I'm going to iterate over all the bars, okay? I'm going to declare the width, okay, and this is going to be the nearest smaller element to the right minus the nearest smaller element to the left -1, okay? And here I'm going to calculate the area, okay? Max area is equals to the maximum between max area and this width cross the current heights, okay? The current height. And after that I'm going to return the max area. So this is all for this question. Let's run the code and see if this passes all the test cases. We have an error here. I have a typo, okay? Hates. Let's see if we have another typo. Another typo. Hates. I think I don't have any typo. So we passed all the base cases in these examples. Let's submit the code to see if this code passed all the test cases, okay? And yeah, as you can see, it's passed all the test cases. We have a verdict accepted, and we have a very good solution, okay? So what is the time complexity for this question? The time complexity, time and space complexity for this question is big O of n, because we are using a vector of size n, and we are iterating over the entire array. So we have a very good solution, okay? So I hope you enjoy this video. See you in the next.